Okay, good morning. So there is one small part of this chapter left, and then we have to decide about another exam, so that we can immediately go to the next chapter. Okay. But there was one problem. I told you that is a little bit more advanced problem. If you are interested in challenging problems, I don't know how many of you even remember. But let me write it here again on the board so that I solve it for you. So it was this equation, and if you remember, we were doing very good in solving equations, but this is, I would say, from a different character type, you know. Minus 1 is equal to 5. The reason that I am bringing up is because if you are interested to see a little bit harder problem, unusual problems, you should see this one as well. So I have a number x, I take the log of x in base 5, whatever this number is, I subtract 1 from it, it becomes a number. That whole number is the power of a square root of x. And the answer is supposed to be 5. So we are supposed to find x. Okay, so please think a little bit about this, and then I will start preparing the lecture for now, just 2 or 3 minutes. The reason I call it a little bit I would call this a little bit unusual or non-standard problem is because you have the unknown both appearing in the exponent and in the base. So in the problems that we have dealt so far, we had this in one place, yes, not in 2 positions. So I can give you a hint because might be you need some guide, but after that I hope that you can solve it. If 2 numbers are equal, what we can say about the logs of the numbers in a given base?
The logs are also
equal. Yes. So now this is supposed to be equal to this one. So the log of this number should be also equal to the log of this number. Okay? But we can have logs in different bases. You need to check which one is more suitable for this problem. So my guide is this number is equal to that number. Take log of this number and equate it with the log of this number, but which base is up to you to decide. Yes? I think you should be able to solve it. Yes?
It's x25.
Yes. Did you solve it or guessed it?
No, after you said that the logs had to be different, I solved it that easily.
Yeah.
Not I guess.
Okay, but just I want to give some time to others. Please do this. Because that part was hard, and now you have one experience in your toolbox. That sometimes if I want to solve a logarithmic equation, I have to think in also this way, take log from both sides, yes? I want to give you time. I mean that you will not learn mathematics if you are not really engaged with the problems. Yes? And by the way, there are so if you have mathematics problem books, they don't give you immediate solutions. The authors who are patient have 2 sections for solutions. One guiding to the problem and one solving the problem in full detail. So if you are disappointed that you cannot solve, you just don't go and see the full solution. You go and see the guide and put a hint. Then you try again. Then if you are stubborn and interested, of course, and persistent, then your problem solving level will actually increase. And it doesn't matter, by the way, which job you will have, solving problem skills is something that you really need in your job. And mathematics is the best place to improve that skill. Okay, so Simon, can I hear your solution? Because I think this is not that easy after even knowing that. I just want to understand how did you do that?
Okay, so we know that 5, we can rewrite 5 to the power of log of 5 with base 5. That is still the same equation.
Yes.
And with that, we can know that log of x with the base 5 minus.
So let me follow yours. Let me just follow yours. So what you are saying is that I repeat the left-hand side.
Yes.
And then instead of 5, what should I write?
5 to the power of log of 5 with base 5.
Yes. That's correct, because log of 5, you can see it in 2 different ways. Log of 5 in base 5 is 1, 5 to the power 1 is this, and then you know that this one and that one are the same, so you can cancel. So in any way that you interpret that, that's correct.
Yes.
Yeah.
And then after that, I took this a bit for granted, but I thought that the logs were equal, and then so log of x with base 5 minus 1 is equal to log of 5 with base 5.
Okay, that's a pure guess. It's not clear, but of course you were lucky.
Yes.
Okay, so you didn't even need to actually take the logs. You just do this comparison, yes? Okay. No, if you don't mind, let me just clean it. This becomes more difficult than you thought, okay? So what I'm telling you is that take the log from both sides. But which base would be more natural in this case?
5.
5, yes. So I would take the log, let me write this. You are telling me that I want to make this right. So I would say that, okay, instead of thinking about this equation, so let me take log from both sides, yes?
Yes.
Okay, in base 5. Yes?
Yes.
You might say why this is useful. We don't know. You have to solve this problem, and then if you get interested in this, you need to remember the trick and hope that someday you can use this trick for another similar problem. I mean, this is the way that you have to think. Okay, but I don't have any problems on the right hand side. Everyone hopefully knows that this is 1. But what do you think I will use here? Exactly. So you see, if you know the rules, it is not that strange. So might be you just by reading the guide, you can continue yourself. So you see that this power appears here. And we know a rule, what happens with this power, yes? So it goes back to the log. So then it becomes log of x 5 minus 1 multiplied, can you tell me what is left?
Log of x.
Not x, the square root of x.
Square root of x base 5.
Base 5. And then this is equal to 1. Yes? And now you see that this is similar to this one. You need to understand out of the box, you know. So you say that, okay, what is your unknown? This is your unknown because you don't know x. But unfortunately, it seems that I have 2 unknowns because they are not identical. But I can make them identical. So what can I do? Can you tell me? Instead of square root of x?
X to the power of
Yes, yes, use them. So this one is nothing except x to the power of 1/2. But then you know the rule, 1/2 will go back. So then if you want to write it, it becomes log of x 5 minus 1 multiplied by 1/2 multiplied by log of x to the base 5 is 1. Yes? And you want to solve this. Can you help me? I want you to learn these things, yes? Don't let the names distract you. Log x to the base 5 is just a name. And it is repeating itself there and there. We had a standard technique for this. What was that?
Combine them.
What?
Combine them. Can you?
No? Well, of course I can combine them, but I mean, I just want to remind you the names. So that was the technique of auxiliary variable. So something is repeating itself over and over. So what I say that I would say let. Of course you can work with this one, but I'm sure that probably it's easier for you to understand it in this way. So you say let. I give it a name. Be capital X.
Okay.
Yes? And then let us rewrite the equation again. So what that equation will be, it becomes x minus 1. If you don't mind, let me put 1/2 here. And what is the name of this one again?
X.
X.
Is equal.
And now this problem is a E-level problem. Yes, so what is your unknown? Your unknown is capital X. everyone should be able to solve, and you did it actually in the exam. Hopefully I haven't corrected that yet, but this was one of the simple problems. This could be in the exam, in the previous exam, because I asked you to solve this equation. It's a quadratic equation. I myself don't like fractions, so I want to get rid of fractions as immediate as possible, so I just multiply by 2. Then it becomes x minus 1, x is equal to 2, and I multiply this in, it becomes x squared minus x is equal to 2. But you know what to do, yes? I move it to the other side. Isn't it simple?
Yes.
Either you use PQ formula or ABC formula, and if you are good in guessing numbers, might be you can also guess by factorization. Yes. I need two numbers whose sum is what? -1, and the product is -2. Can you guess those numbers? If you can do it faster. Otherwise,
-1 and 2, I guess.
2, what are?
-1 and the 2.
No, because -1 and the 2 becomes...
It's minus.
Yeah, so it is
Minus
2 and
two.
-1. -2 and 1.
Yes.
Yes. If of course you cannot guess, you have to spend a little bit more time to use the formula to find x. But now the answer is either what? 2 or
2 or
-1. But this is the auxiliary variable. I am not looking for the auxiliary variable. I am looking for my original unknown. So that's easy now. I would say that if x turns out to be 2, if capital X turns out to be 2, then it means that the log of x to the base 5 is 2. Okay, tell me, what is x then?
25.
Yes, x is 5 to the power of 2, which is 25. So this means that x is equal to 25. But before putting it in a box, you have to make sure that you don't get any problems. Yes, x should be positive sanity, so no worries. If you want, you can check. Put 25 here. What is log of 25 in base 5? It's 2. -1, it's 1. So this one is 1, and then you have a square root of 25, which is 5. So that's correct. But let us see what happens for the next one. If capital X is -1, what happens? Logarithm of x to the base 5 is what?
-1.
-1. And then what happens for x? Can you tell me?
1 over 5.
1 over. Yes?
Yes.
But is 1 over 5 acceptable?
It's a false root, I think.
No, at least it doesn't seem to be false. Because 1 over 5 is actually acceptable for a square root. And that's also positive. So that's also acceptable for this one. Yes? But is it true or false? By the way, I don't think they could find it in the book themselves. But let us check. I think 1 over 5 is also correct. Yes, let us check it. Let us check. Of course, you don't need to doubt because everything was drawn right, and 1 over 5 is acceptable both for the square root and for the log. But let us, by the way, try to see. So one solution was really 25 and you were able to guess. And that's what I'm saying, that if this turns out to be another solution, so it seems that guessing is not that good because you might lose other solutions. Yes? So let us check, is 1 over 5 correct or not? So what you need to do, you need to replace x with 1 over 5 everywhere to see if it works or not. And I want to ask you questions. So let us calculate this to see if this is really 5 or not. Okay, can you help me to do that? First of all, instead of this one, I can write it simpler because the square root of 1 is just simply 1, but of course I have to live with the square root of 5 here. To the power of. Can you tell me what is this number?
It's -1.
It's -1. And then I have another -1. Then it becomes 1 over square root of 5 to the power of what? -2. But I can inverse this. I can write the reciprocal, and the price that I pay is to get rid of this minus sign. Even better, yes? And what is the answer?
It's 5. Oh.
So that answer is really 5. And that's a good, I wanted to try to convince you guess is not good. At least you were able to guess that one, but not this one. And it means that your solution is not complete because you lost one solution. So this was actually a very nice problem, I would say. But it is completely at the level of your knowledge. I really want you don't underestimate yourself, okay? Yeah, try to work harder. You can achieve higher goals easily. Any questions here?
So the strategy in this kind of problems is that you take the log of both numbers.
No, I cannot. I cannot give you a recipe.
Uh-huh.
If I could, then math will not be fun anymore.
Okay.
Because you know what to do with everything. The point is that by looking at this problem, I would say that you have one extra tool in your toolbox, and the toolbox is mathematics solving problems box or something. You need to remember that sometimes this trick is useful. Yes? That's it. If you don't mind, let me start teaching today's lesson so that we are sure that we are not behind. And then I will come back to actually a little bit harder questions, both in this new topic and that one. First of all, let's also go back to our lesson. The lesson today is called Exponential Equations. Okay, can you expect by the name, what do I mean by an exponential equation before I describe it for you? Anyone else?
Exponential equations.
Yes?
Equation involving powers.
Better than that. Because x squared is equal to 4. X squared is a power. X is called the base, 2 is called the exponent. And now I am telling you exponential equations. Yes, Rasmus?
I guess equations where the power is x over x.
Exponent.
As the exponent.
Exponent is the unknown one. So let me just tell you one might be you don't appreciate this. If you write a to power m, this number sitting here is called the base. This number there is called the exponent. And sometimes I also use it wrong. But this is the exponent, this is the base, and the total expression is called a power. Yes? So when I say exponential equation, when I see the word equation, it means that I am involved with unknowns and I'm supposed to find them. But when I say exponential equation, it means my emphasis is on exponent, on to be unknown. So in an equation that exponent is unknown, that's called an exponential equation. Might be the simplest possible exponential equation ever is 2 to the power of x is equal to 2. So I am asking you find x. So what is x? 1. Yes? So x is 1. So I want to, first of all, review a little bit about Math 1C lesson. We did this before, but we can expand the variety of problems that we can solve to the more diverse. We can solve more diverse problems now. For example, if I give you 2 to the power of 2x is equal to 8, you can still solve the problem. What you need to do, you need to write both of them with the same base. So if a is positive, and if a is not equal to 1, and if someone tells you that a to the power of x is equal to a to power y, what you can conclude immediately?
X is
Equal to y. So that is the general strategy, which sometimes fail to work. Why? For example, of course it doesn't fail now because you have enough knowledge. So if I ask you 2 to the power of 2x is equal to 8, find x, I think it's very, very simple. What you do, you write 2 to the power of 3 instead of x, instead of 8, and then you have this problem. 2 to some power which you don't know is equal to 2 to this power. So what is the consequence? So you can immediately conclude what happens if this is going to work. This means that this power, this exponent, is equal to 3. And this means that x is what?
1.5.
3 over 2 or 1.5.
Yes.
But now let me change this problem from 8 to 7. In Math 1C you were not able to solve it, but now you can. Yes? So if I just change this problem to 2 to the power of 2x is equal to 7, and I ask you find x. That problem, we couldn't solve it in Math 1C because we didn't know how to write 7. So whenever you have an exponential equation with a given base, if you are supposed to succeed to solve the problem, you should be able to write the right-hand side also in the same base. But do we know in Math 1C, did we know in Math 1C that 7 is 2 to which power? Not exactly, yes? But now we know. Can you write 7 in the form of a power whose base is 2?
Log of 7 to the base.
Yes, but we learned that, yes, log of 7 to the base 2. So any number can be written in any base that you like. Yes? So this means that 2 to the power of 2x is equal to this. It means that 2 to the 2x is what? Log of 7 to the base 2. Yes? And then you are looking for x, so x is 1/2 this number. That's your answer. Exactly. But of course, if you want to get a feeling of what the value of x is, you to put this in the calculator, you get some decimal points. So that's an approximate value for the solution, but that's the exact value. Is that clear?
Yes.
The method the book describes is not this. I think this is better. Both of them are good. So let me say, for example, the book that uses, because in calculator you don't have this button to calculate this, they prefer to calculate everything in the base 10. Okay, so if you want to solve this problem, if you write this, that's acceptable for me. But if you want to really do something, you can do another. So what they do, they take logs from both sides, only in base 10, regardless of what are the bases here and there. So they take, if you say this number is equal to that number, then I can conclude that the log, you see that's the same strategy, but in a very, very simple context. Log of this is equal to log of 7. Yes? And then what happens, this 2 to the power of x goes back to the log, so it becomes 2x multiplied by log of 2 is equal to log of 7. But your goal is to find x, so you have to make x alone. But there are 2 factors involved. One of them is this one. You have to divide by both of them to make x alone. So then x becomes log of 7 that you had on the right, divided by 2, and another one divided by log of 2. So that is also quite acceptable if you write. And by the way, are these 2 answers exactly the same or not? Because if they are not, I am in trouble. I am getting 2 different values with the same equation. Are they the same?
Yes.
We learned that, yes? We learned that log of 7 over log of 2 by the change base formula is exactly log of 7 to the base 2. So I don't know which approach do you want to follow. Both of them are actually quite good. But this is probably faster because this gives the priority to logs with base 10. But why 10 is so important, I don't see any point for that. So if you prefer to work only with logs in base 10, then you have to follow this. If you don't have that preference, you can start working with logs in different bases. So that is the core of today's lesson. So that I want you to feel that's actually a big success. So because in Math 1C, you couldn't solve that. You could solve this, but now you can also solve that. Yes? Is that clear?
Yes.
Okay, but the problem, I want to give you more examples. That is up to you. I will also refresh your memory a little bit here. So sometimes, if these are good numbers, they are related with powers, you don't really need logarithm. You need to write them with the same base and compare the exponents. I want to refresh your memory a little bit about what we learned in Math 1C, and then we go a little bit some type of problems that we need to do right now. And then we are done, okay? We can solve them a little bit harder problems together. Okay, so let me just clean the board for the time being. Okay, so I was call this recap, yes? A little bit of what we had at the level of Math 1C. Of course, I will increase the level of difficulty here because now you are more experienced. But you don't need logs in general. Okay. For example, let me just write this one for you. We want to find x. Solve the following equations, yes? So if you want, I can emphasize. Okay, so let me write this. 1 over 49, I don't know if that is hard, but to the power of x minus 1/5 times 7 to power x is equal to 343. Okay, so this is categorized under the title of exponential equation y, because the unknown that you see appears in the exponent. And if you don't know about this number, let me guide you. 347 is 7 to power 3. Yes? Of course, in principle, I shouldn't guide you. This is of your duty. When you see that this one, the base here is 7, the base is not 7, but it is related to 7. Yes? Because 49 is 7 to power 2. So if this is related to 7, and this is already 7, you should guess, might be this is the case, that this is also related to a power of 7. If you have this guess, then it is not hard to explore it. You just divide this number by 7, it becomes 49, and then you immediately realize 49 is 7 to power 2, so therefore it becomes 7 to power 3. This is the way that you have to think. It's related to power 2, 7, power 7, power 7. So you really probably don't need any logarithms here. So because you can compare them. Okay, tell me what is your starting point. Help me to do that, yes. So as soon as you see that every number involved, every number somehow is involved with the power of 7, you might understand that this is a Math 1C problem, not a Math 2C problem. Yes? So how can I continue?
Rewrite 1 over 49.
Yes, so I will start writing in the powers of 7 because you know the goal. What is the goal? The goal is to have some kind of this combination at the end. That these are the same, and then you can conclude that these should be the same. That is the strategy. So I already gave you the hint. So 7 to power 3 is 343. So I don't have any problems with the right-hand side. It's a power of 7. And I have to start writing the left-hand side, if possible, as one single power of 7. So what can I do? I can write 1 over 7 to power 2. And of course, I would recommend you, if you are good, you can just do these things much quicker than this. And then 7 to the power of x. Okay, what is the next step? Can you help me? I cannot do anything with this. I cannot do anything with this. I can copy and paste them for the time being. So what can I do for this?
7 over 2 is 7 over minus 2.
Yeah, because I want to have 7 as the base. Yeah, so I will bring it up. So 7 to the power of minus 2, and then to the power of x minus 1 over 5. Okay, I don't know, so I cannot do anything with this. Copy and paste, copy and paste. But I can do a little bit better here. What can I do?
Does minus 2 multiply by both?
Yes, minus 2 will be multiplied by the whole exponent here. It becomes 7 I multiply, you can do it in your head. Minus 2x times x is minus 2x, but you need to remember you have to multiply minus 2 by this number as well. It becomes positive 2/5. Yes. And if you don't mind, let me bring this a little bit lower. That was not the right place. Okay, what is the next step? I want to have one single power of a on the left, one single power of a on the right. So how should I do that one? What's the next step?
Put them in an equation, I guess. Like
No, what do you mean? 7 to some power is multiplied by 7 to another power. You have to add the exponents.
Yes.
You write the base and add the exponents, yes? So this becomes 7 to the power of minus 2x plus 2/5 plus x. And now I reach the goal, yes? I have two powers. The bases are 7, and then I compare them. So the exponent on the left should match with the exponent on the right. So then it means, of course, x minus 2x has a better name, it's minus x, and then I have 2/5, and then on the right-hand side I have 3. And this is a very, very simple equation now. So I just move this to the other side, and then you do this calculation. Hopefully you are fast enough. What's the answer, by the way? 2 seconds. 3 minus 2/5? 13 over 5. Because you multiply this in your head, 15 to subtract, it's 13, yes. And then what is x? X is negative 13 over 5, which was, of course, we couldn't guess at all. Yes, I don't think we could guess that this number. We are really doing something. So we were able to find this x, not guess, which was not possible. So x is minus 13 over 5. Yes, is that clear? Of course, even in Math 1C level, the problems could be hard. I don't know if you have any clue, for example. Let me give you another problem and wait for you to see how you act. Okay, let me write this for you. A 3 to the power of x plus 3 to the power of x plus 1 plus 3 to the power of x plus 2 plus 3 to the power of x plus 4 is 360. No, up to, sorry, that is 3. 1, 2, 3. I don't know why I jumped before. So you want to find x. So this could in principle be a Math 1C problem, a hard one. But it doesn't need logarithms, you will see why. So I have fine-tuned this number, the person who designed the question. They have fine-tuned this number so that you don't need the notion of logarithm at the end. I can give you a little bit of time. Please do it, otherwise you will not learn. Yes?
Is x equal to 2?
I don't know, but 5, yeah, it seems to be right. Yes. So how did you do that?
Okay, so I started by, we have 3 to the power of x plus 1, 3 to the power of x plus 2, and 3 to the power of x plus 3. I started by taking out the plus 1, plus 2, and plus 3, so it is 3 to the
Okay,
power.
let us do that, that's correct. So let us just, so what he's mentioning is that he probably repeated this one, but instead of this one, I hope that you agree you can write 3 times 3 to the power of x. Yes? because the power here is 1, if you multiply them, I told you that usually this is the simpler problems. If I give you this, I'm sure that you can write this. But sometimes it is needed that when you have this, split it up into 2 factors. Yes? Okay, and then what you do here, you can write 3 to the power of 2 multiplied by 3 to the power of x. And then what you do here is 3 to the power of 3 multiplied by 3 to the power of x. And then you copy and paste for the time being the right-hand side. But of course, there are better names. I mean that if you are not in hurry, you can do it patiently. Instead of 3 to the power of 2, what can I write? I can write 9, because that's a better name. And instead of 3 to the power of 3, I can write 27, 3 to the power of x is equal to 360 degrees. 360, not degrees. Okay, so then what to do?
So we have 3 to the power of x. We can kind of act like it's a variable.
Exactly.
So
that means auxiliary variable. So
yes.
in principle, you can say that I would call 3 to the power of x a new variable. And then I can rewrite the equation. Wherever I see 3 to the x, I can write x. And then this becomes 3 times x. This becomes 9 times x. This becomes 27 times x. And on the right-hand side, you have 360. This is a math, E-level Math 1C problem, yes. Everyone knows what to do. Because I have x plus 3x is 4x, plus 9x is 13x, plus 27x is 40x. So this becomes 40x is equal to 360 degrees. You want to make x alone, so you divide by 40, and it becomes 9. But this is your capital X, which was not in the problem in the beginning. You introduced it to simplify your problem. And now you have to go back and find the little x, which is your goal. Okay? So I would say that if x is 9, I replace this capital X with 9, and you even don't bother to just guess. X is how much? 2. So, I mean that even in that level, you have to be creative. Yes, it doesn't mean because you could solve it in Math 1C, it is necessarily a simple problem. So you have to be creative in how organizing the problems. Okay, but let me now see. Now let me, for example, now we go to a little bit to Math 2C level. Okay. So what do you think about this problem? By the way, if you have any questions, please interrupt me, okay? I assume that you understand, so I don't ask all the time. So, if I give you, let me think a little bit. So let me write 4 to the power of x minus 5 times 2 to the power of x is equal to negative 6. Let us solve this problem. I want you to find x. Could you solve this?
I could solve it, but we can see the answer is 1, but I got something else than 1.
1 is correct?
Yes, but I got x is equal to 1 plus log 3 base 2.
Definitely this should have 2 answers. 1 is one of them.
Okay.
But that is, I don't call it solution, even if you can guess, that is not the solution.
Yes.
When I say solve, it means that if you want to guess one, you have to prove me there are no other solutions. And believe me, proving that there are no other solutions is harder than solving the problem. Okay? So I would say that if I want to solve this, then I think the method of auxiliary variable is still helpful.
Yes.
Can you see it how? How can you tell this?
4 to the power x, we can write it as 2 to the power 2
Yes,
times 2 to the power 6.
exactly. So what you do, the first thing you do is to write 2 to the power of 2 to the power of x. For the time being, copy and paste these parts.
Yes.
And then can I interchange these two, by the way?
Yeah.
I want to, you see, you have to, understand these things better. So if I write a to the power of m to the power of n, what is the answer? The answer is a to the power of mn. If I ask you what is a to the power of n first and then to power n, m, you will get the same thing, yes? So this is, you remember, you can always, if you want, you can interchange the powers, the exponents here. So when I change the exponent, something nice happens. You see that 2 to the power of x is repeating itself here and there. So it is a good strategy to call it something new, yes? And then I put it here. This becomes x squared minus 5x is equal to minus 6. It is the E-level question in the exam that you did. Yes? You are supposed to solve for x. And then I move 6 to the left because that's a quadratic equation. And then if you don't like guessing, you can use ABC formula, you can use PQ formula, but is it easy to guess in this case? I need two numbers whose sum is minus 5 and the product is 6. What are those? Minus 2 and?
Minus 3.
So this means that capital X is 2 or capital X is 3. Yes? And now, capital X is not my goal is the little x. So what I do, so you see that your guess was correct, but I don't know why did you make the second part a little bit more complicated. So x, capital X is 2, then it means that 2 to the power of x is 2. So that is very clear. That
I made a mistake on the second one.
Yeah, I think so. So this is one. But you see, that's not the whole story, because there is another problem which you couldn't guess because it involves logarithms. Yes? So x is 3. So then it means that 2 to the power of x is 3. I don't know, if you want to prefer to work with logarithms in base 10, you take logs, or you can use the base 2. So I don't see any problems with working with base 2. So what can you say about x?
Log 3.
Log of 3 to the base 2. And that is not what you could guess. And if you just write this, this is not complete because there is another solution, and that is this one. And this is the one that we couldn't solve in Math 1C because of this part. Not because of everything else. By the way, you didn't know about how to solve quadratic equation in Math 1C. Yes?
Would you still get a point if you only wrote the upper?
No, by guessing, no. But if you just say that I guess that x is equal to 1, no. And by the way, it was not hard for me to design questions that you couldn't guess. Because I could choose these numbers in a way that, for example, instead of this one turns out to be 2, turns out to be 5. And then 3. And then you have to, both of them will be in logarithmic form. Yes? It's not hard to design those questions. Okay, so this is actually the new lesson. So that's an exponential function. Why? Because you see your unknown is on top. Okay, I don't know. The lesson is finished here, but I will continue writing some problems for interested students on the board. If you are not that interested, you can just go and do what was written on Google Classroom before. But I recommend you that there are some problems I myself am curious to solve. I cannot resist when I see a nice problem. So let us do it together. And by the way, you know that according to Jordan Peterson, I don't know how many of you know him.
I know.
One of the severest possible case of addiction is math addiction. Yeah, so that is somehow, if I am right and understood it correctly, so you really feel that you have to do mathematics. Yeah, that's a good addiction, by the way. Yes. It's a positive addiction. I don't know if I understood him correctly, because that was just one part of some very long talk. Okay, so let me just write this on the board to see if you can solve it for me. So I have this log. So this is optional. If you're not that interested for hard problems, just you can do something else. So this one. The reason I don't know, this is not probably very hard, but this shouldn't be hard, but I want to see how do you think about the problem. So log of x to the base 3 plus log of x to the base 5 is supposed to be equal to the log of 225 to the base 3. Okay? So let us see how this will work. In the meanwhile, I will start updating the Google Classroom, so if you are not interested in these problems, you can start working on the problems that you have to learn. Okay, another problem that catches my eyes is this system of equations. I will write also that one as well. My video will not have time to solve it, but I will solve it for you at some point. I hope that you can solve it before I do it for you. So, I mean that there is no reason that we just solve systems of equations just with x and y and things like that. But this system is a nice system. You are supposed to solve for x and y. Oh, 5 over 2, sorry. And then x plus y is 6. So this is a system of equations now. It's a system involving logarithms. So there are two unknowns here, not one, x and y. So you are supposed to find both x and y so that it fits both equations simultaneously. That might be also a good problem. I don't know. I haven't seen this before. We can also solve it together. But first that one. And I told you, okay, any ideas about that problem?
This?
Yes.
So I wanted to change the base 5 to base 3, so I took log of x to the base 3 divided by log of x to the base...
Okay, so let us follow yours. I can trust you here, so let us see how it goes. So you are telling me that, no worries, but this is the point, this is the nature. I even don't know myself now. I have to start thinking how should I do. So but I will follow yours. At least this is good, because you have some strategy, because you are telling me that, okay, this happens with base 3, that one happens with base 5. Unfortunately, I don't have anything to do with them unless I want to make them to the common base. So that's good. But what you told me, you just wrote x
log x base 3 divided
and then log of...
But the thing that I was unsure of is that if I can write this division expression as log of x minus 5 to the base 3 instead.
No, that was my impression, and my impression was right. You get distracted, you need to teach this part to yourself. That is the hard part, you did it. But suddenly you get distracted. First of all, you see, this is an auxiliary variable. So just write it. Capital X plus capital X divided by this. I want to teach you something. I'm just drawing your attention to it. I cannot go drill it to your brain, okay? But if I give you this, could you solve this problem or not?
Yes.
But for some reason you cannot do this. This you need to teach yourself why I could solve this, but I cannot solve this. They are exactly the same problems. But because you see very friendly numbers here, you don't freak out. But you don't see friendly numbers here, you freak out. In general, that is a number. Is that clear or not? Can you tell me how do you solve the problem here? Multiply by 2. So how do you solve the problem here? Multiply by this guy. Yes? So this becomes logarithm of 5 to the base 3 multiplied by x. Then this is gone. It becomes what? Plus just x. And then I have to live with it. I will do something for it later. Okay? So I will multiply this one here as well. Yes or no? Okay. Now can you tell me, if I want to test your understanding again, what I'm supposed to do on the left hand side then? What can I do on the left hand side now? No, let me ask you again the same question. If I ask you to solve this, you could. What do? You write 3x. The reason that you write 3x because you say 2 plus 1 times x. But because these are so simple, you do it in your head, even you don't recognize that you are using distributivity laws. So this is the same thing, I factor it out. Yes?
Yes.
So then it becomes what? Log of 5 to the base 3 plus 1 is equal to x, times x is equal to this guy. So log of 5 to the base 3. So we have to be patient a little bit, but in principle,
That's 4 involved.
okay, I have this one. And then I want to find capital X. So what is capital X? I have to make it a log. So I have to divide by this number. So this X becomes complicated, but who cares? You were able to find the answer. But then another challenge is that if I can make it more beautiful, beauty is something I really believe that you have to care about.
You write the right hand side as 4 log of 5 base 3.
So let us see. But first of all, don't lose the logic. I didn't want capital X. I wanted to calculate what? Little x. So this means that still I am not done, but in principle I am done. Why? Because log this x can be replaced by this guy is equal to this very strange number, but that's a number. Let me write 1 first, if you don't mind. Okay, now can you help me? What is x then? In a matter of seconds, you should tell me what is x. 1, 2, yes?
225.
I don't know, it was very fast. I don't know, did you simplify it in your head?
Yes.
But, okay, so let us just wait. What is x? Again, you are making the same mistake 3 times in the same problem. Log of x to the base 3 is 5. What is x?
X is...
You see, this happens 3 times here.
Uh-huh.
You could solve this one, but you cannot solve this one. You don't respect what I'm saying. Yes? So x is 3 to this guy.
Yes.
You see, this is 3, that's the 3rd time that happens in one single problem. Okay? So this means that x is 3 to the power of this one. This is, by the way, I want you to understand, this is done. Might be this is ugly, but this is done. Is x, what is the x? You can put at the end this in the calculator and you got it. And that is your number. But then the challenge starts from here. If you're interested in mathematics, I might say that, okay, is there any way that we can simplify this more? That's a different problem. Okay, that's a different, beautiful problem. Can you say, so, but I want you to understand, if I don't know, if it has 5 A points, if you reach there, I will definitely give you 3 A points. If we can simplify. Sometimes we really cannot simplify, and that I will give you the 5 points. But I want you to understand, this is important. This mistake happened in this problem 3 times. Take lessons from it, yes? Okay, now the question is that, now Sergey, I want to hear from you. Could you really simplify that?
Well, log of 5 and base 3 appears in both the denominator and the...
Yeah?
So I just simplified them.
No. If 1 was not there, you were able to simplify.
Yes.
1 is there, you cannot simplify. You can only simplify factors. It's not a factor, this is a summand and that's a summand. You can only simplify factors. So that is not on the table, yes?
So if we can write 1 as a log of 3 to the base 3 and then it's addition between those two.
Yes,
Then we can.
it works. So let us continue. So what happens is this. You want to add something? I think his method is
On
correct.
the top one as well, you can...
You can work here. That's also equivalent way of doing it. Yes. So let me follow yours. So this becomes x is equal to... Let us copy and paste these 2 parts for the time being. By the way, you need to be a little bit friend with numbers. So 225 is a famous number when I look at it. What is that number? It's 15 to power 2. That's the only, if you don't see it, it's a little bit hard for you. So if you 15 to power 2, this power of 2 goes to the back of the log. So this becomes 2, log of 5 to the base, and log of 15 to the base 3. And now what you told me will solve my problem. Sorry, x is 3 to the power of that. Yes? So, and then you told me instead of 1, I write what? Log of 3 to the base 3, and combine it with that one. What happens?
3 times 5.
3 times 5, which is exactly what I need. Now, Sergey, I am allowed to simplify them right now, because now they are factors. And then what happens? Extremely nice problem. Are you excited? Yes. So this 2 goes to the, so let me, this 2 goes here, it becomes 25 to the 3. And the answer is surprisingly simple, 25. Yes? But I just want you to learn something. This was a coincidence. The designer of the question designed the numbers in a way that you can get a very simple friendly number at the end, which is not necessarily the case. Is that understandable? So I want you to understand this was the important part, that this is indeed your solution. Is that clear? But you made that mistake 3 times, but don't let this happen for the 4th time in the future. Okay? Thank you very much.